In this lecture, we will be discussing how to implement half adder and half subtractor using 4 to 1 multiplexer. Now, what is a half adder? An adder is a digital circuit actually which performs addition of binary numbers. In case of half adder, we will be able to add two single binary digits. In our case, we will consider that to be A and B. And it has two outputs. Usually one of the output is called sum and the other one is called carry. Now the carry signal represents an overflow into the next digit of a multi-digit addition. Now if we write down the truth table of half adder, obviously there are two inputs B and A, so there are four possible combinations: 0 0, 0 1, 1 0 and 1 1. Now if we all know what is the output of a half adder. So when we talk about the sum, when the inputs are 0 1, whether it's 0 1 or 1 0, the output will be 1 as seen in this truth table. And when both the inputs are 1, the carry is 1. So if we write down the expressions for sum and carry, so if we consider the table for sum, this is 1 when the input is B bar A. Similarly, it is 1 when the input is B A bar. That means B is 1 and A is 0. And in both these cases, if the combination is 0 1 and 1 0 at the input, we will have an output high at the sum output. So what we can do is we can write the sum of product form in this manner, where sum is nothing but B bar A and B A bar. Similarly, if we talk about carry, only one of the output is high, and this is when both B and A are 1. Hence, carry is nothing but B and A. So now let's try to implement the same thing using 4 to 1 multiplexer. Now in our previous lecture we have already seen that 4 to 1 multiplexer is having the output expression as I0 S1 bar is 0 bar, or I1 S1 bar is 0, or I2 S1 is 0 bar, and I3 S1 is 0, where I0, I1, I2 and I3 all are inputs. Now if we consider the diagram here, where we have also included only one output of the half adder, which is the sum, and if we write down the output expression of the multiplexer, which is given here, and also the sum, we can see there are only two terms, that is B bar A and B A bar. Now this can again be rearranged in this manner. Now B bar A is same as 1 dot B bar A. That means whatever be the combination at the B bar and A, that will get reflected at the output. Hence this particular term can be written as 1 dot B bar A. Similarly, this particular term can also be written as 1 dot B A bar. Now there are two terms missing, so that can again be written as 0 dot B bar A bar and 0 dot B A bar. Now what we have to do is we have to substitute the variable S1 and S0 using BA. So if we consider S1 as B and S0 as A, the select lines as B and A, then, and if we compare the output expression of the multiplexer with the expression of sum, we can see that S1 bar S0 bar is similar to B bar A bar. S1 bar S0 is similar to B bar A. S1 S0 bar, which is similar to BA bar, and S1 S0, which is similar to BA. So now what we have to do is we have to compare the inputs. Now if we take B bar A, the B bar A is similar to S bar dot S0. So the input is I1, and in this case it is 1. So I1 now can be connected directly to plus 5. Similarly, BA bar. Now compare this to the expression here. We can compare it with this particular term, and it is having I2, which is 1. So what we can do is connect I2 with plus 5. Similarly, the other two terms are having 0. That means you have I0, which can be compared to this particular term. Here it is given as 0, so we'll connect that to the ground terminal. And here we have another term, which is BA, which is S1 S0, and input is I3, which can again be compared to 0, hence connect this to 0. So if we apply 0 0 at the select lines, so as if we are providing input to the half adder, then the input line I0 gets selected at the output. Now when 0 0 is selected, then the output of the half adder should be 0. Now since I0 is selected at the output during this combination and it is connected to ground, we will get a 0 at the output. Similarly, if the input is 0 1, then I1 is selected. Now I1 is 1, so we will get an output 1, which is similar to this, the second one, and the third one 1 0. If we provide 1 0, I2 gets selected at the output, so I2 is again connected to high, and we get a high at the output. And when it is 1 1, the input I3 is getting selected at the output. So S1 is 0 combination when it is equal to 1 1, and I3 is getting selected at the output, and since it is connected to ground, we'll get a 0. So this particular circuit now actually is behaving as a half adder, one of the outputs, so that is the sum. So to implement the same thing in a similar fashion, if we have to implement the carry, what we'll have to consider another circuit where we'll have to consider the output of carry. Now if we see, the carry is BA. Now again we are considering S1 as B, S0 as A. So this particular expression where carry is BA can be extended to B bar A bar, B bar A, BA bar, and BA. Among the four terms, only one of the term is available. Therefore, other terms are nothing but 0.B bar A bar, 0.B bar A, 0.BA bar, and the last term which actually is available is 1.BA. We all know that 0 at 0 inside entering into an AND gate, the output will always be 0. So this particular term is always 0, hence it is not available at the output in this particular expression. So this particular expression can be expanded in this manner so that we can compare this expression with the expression of the multiplexer. Now in the very similar fashion, if we compare B bar A bar, we can compare S1 bar, S0 bar. So the input is I0, therefore I0 should be 0. Similarly, the second term I1, this is given as 0, so again I1 should be connected to 0. Now the third term I2, again it is 0 and it should be connected to the ground. And the last one where S1 is 0, is I3. I3 should be 1, hence we can see from the diagram I3 is getting connected to 1. So in this fashion we can implement sum using one multiplexer, carry using another multiplexer. So to implement half adder using 4 to 1 multiplexer, we can actually use two multiplexers working simultaneously. One of the output will give the sum, the another output will give carry. In the similar fashion, we can implement half subtractor using 4 to 1 multiplexer. The procedure is exactly same. Now first of all, the subtractor again is having two binary digits A and B, and it has again two outputs. One is called the difference, the other one is called the borrow. Now borrow signal represents again an overflow into the next digit of a multi-digit subtraction. Now if we talk about the half adder, now in this case the difference output, which is given here as D, is exactly same as sum, which is 0 1 1 0, and the borrow output is the only change that we can see from the half adder. Now in this case borrow output will be 1 on when a larger variable gets subtracted from a smaller one. That means a larger number getting subtracted from a smaller number. So the borrow here is 1 and the other things remain the same. So if we write down the expression for difference, it is same as sum, and only change that we can see here is the borrow. The borrow is B bar dot A. Now again, if we try to implement this using multiplexer, the same thing happens in case of difference and sum. The circuit is the same because the expression is the same. So again, using the comparison technique, we will first expand the expression for difference, then we will compare the terms and put the logic at the inputs, which is same as in the case of half adder for sum. Now if we talk about the output for borrow, only difference here will be that the term that is being used here is separate from the carry. So again we'll have to expand this. If we expand this, we get the expression 0 B bar A bar, 1 B bar A, 0 B A bar, 0 B A. Hence the only term that survives is B bar A. Now again, if we compare the expression of borrow with the expression of the multiplexer, we can see that I0 will be 0, hence I0 is connected to the ground. I1 will be 1 and hence I1 is connected to plus 5. Similarly, I2 is connected to again ground. I3 is connected again to ground. So if we just try to see this logically, you can see if we apply 0 0 at the inputs here, at the select inputs, definitely I0 will get selected at the output. Now I0 is, since it is connected to 0, we will get an output 0. Now the first section for this is true. Now again, if we apply 0 1 at the select in, I1 gets selected at the output. Now I1 is connected to plus 5. Now we can see the output will then be high. So the second section is correct. Then again, if we go for 1 0, the third line gets selected, that is I2. Now here we must get a 0. Since I2 is connected to ground, output will be 0. Again, if we check the last one, if A and B are both 1 1, the output should be 0 as per the borrow output of the half subtractor, and since I3 is connected to ground, we'll definitely get a 0 at the output. So what we can see is the multiplexer now, this particular multiplexer provides us the borrow output of the half subtractor. So in this fashion, what we can do is we can implement half adder and half subtractor using multiplexers, that is 4 to 1 multiplexer. I hope the lecture has provided you a very basic knowledge about implementation of half subtractor and half adders using combinational circuits, that is basically a multiplexer. Thank you very much for watching the video.